So Perkins Winter 18 number 4 is a related rate, which is the classic flashlight problem. So you have a flashlight lying on the ground, lighting up a wall, but a person standing here, a 6-foot tall person, making a shadow. So Y here is the shadow that the flashlight's making. And they say that the flashlight's 30 feet from a wall. So this distance here is 30 feet, and we just make sure we're always dealing with feet. Make sure they don't try to fool us, and so we'll just not use units and know it's in feet. I think they give feet everywhere, so we're safe. Okay, 30 feet. She's 6 feet tall, so that's good. So that distance is 30. And this Isabel person is walking towards the flashlight at 3 feet per second. So she's going this way at 3 feet per second. So let's call that, well, okay, 3 feet per second. And that's x, then they labeled a picture for us. X is the distance from her to the flashlight. So we can say that x dot is 3, and x is getting smaller, so we got to be careful that it's -3. And we know it's feet per second, so we know our time is going to be seconds and the unit's going to be distance is feet, so we'll just keep it like that. Okay, so x dot is -3. And we want to know what y dot is. So she's walking at 3. We want to know how fast the shadow is getting bigger, right? As she gets closer, she's going to make this taller here. The shadow is going to get bigger. So we want y dot. And we know it's going to be positive because it's getting bigger. And we want y dot when she is, how far? 18 feet from the flashlight. So when x is equal to 18, x is changing by 3 feet every second. We want to know when x is 18. Okay, that's the problem here. So this is a related rate. We know how fast she's walking, so now we want to know how fast x is changing. Now we want how fast y is changing. We relate this rate to that rate. So we need some kind of formula to do that. And since we have triangles here, probably similar triangles is the way to do it. Relate the two different triangles because they're all the same. So let's do that. It doesn't matter which one you put on top or the bottom. Let's do the small triangle. 6 is to x, so this side is to that side. So 6 is to x as y is to 30. That's always 30, right? So the big side is 30. So y is a big triangle. This is always 30. So as y is to 30. Okay, we want y dot, so it makes sense to solve for y. So y then is multiply both sides by 30. 30 times 6 is 180. So y is 180 over x. Y is 180 over x. I think that makes sense. Okay, we want y dot. So now we just take the derivative of this equation of both sides. Derivative of y is y dot. This is 180 x to the -1. So derivative of x to the -1 is -180 x to the -2 times x dot. Let's rewrite this in a way that makes sense. So now y dot is -180 x dot divided by x squared. So we want to know y dot when x dot is -3. So that's -180 times -3. And when x is equal to 18, right? So x dot was -3. She's walking 3 towards, and x is 18 when she's 18 feet away. So that's over 18 squared. Is that going to work out nice? Not sure. So 180 times 3 divided by 18 I get 1.666666, which is 1 2/3. 1 2/3 is 5/3. So we'll just say, and it's positive, right? Because those two cancel, the negatives cancel. So it's 5/3, and our units again are feet per second. feet per second. And we know we wanted a positive number, which we got, y, so the shadow is increasing at 5/3 or 1.666, whatever, feet per second. So that is the end of the problem. Not too bad. The tricky part is just really understanding what's going on, making sure things are negative. They're supposed to be negative, like x dot, because it's getting smaller. If a quantity is getting smaller, it's got to be negative. And then using some way to relate it. In this case, we relate it with similar triangles. Sometimes use a volume formula or an area formula, or use a Pythagorean theorem, x squared plus y squared equals r squared, and you take the derivatives of that. Sometimes use sines and cosines and tangents, like the ones we've had on quizzes, but you always relate what you know to what you don't know. Take the derivative. Be really careful with derivatives. It's all implicit. You always get the dots, and then plug in the numbers they give you. Okay, great.